Hey folks, Doug Blake with Body Design University. In today's video, I'm going to talk to you about a concept that some students have asked me about recently, and it's in chapter 10. Now, I know last week I was talking about interestingly enough, in chapter 10, about the postural distortions, the issues related to lordosis, kyphosis. And it's interesting because this topic of what's known as the length tension relationships is very important. They tie together quite easily when it comes to trying to memorize these concepts. You know, when you look, and by the way, I'm on page 394 and 395, just as a sort of a prelim. When we talk about length tension relationships, we're talking about the muscles themselves, but technically we're really digging a little bit deeper into what are known as the sarcomeres. And you're going to, if you haven't seen it already, you'll read through it. The thing to keep in mind is that we want to understand the basic concepts. Okay, it's not necessary to delve too deeply, and ACE does not do that anyway. So in this video, just want to help you to understand a little bit about what length tension relationships are all about. But it's going to help you, this is the point, is that it's going to help you to go back to page 394 and look at these postural distortions, because there's a reason why your posture and your joints and everything get out of whack and lead to these concepts known as lordosis, kyphosis, and sway back. So length tension relationship merely describes, and again, we're talking about muscles that are shortened or lengthened, but it really occurs at the level of the sarcomere. If you remember, the sarcomere is when we talk about inside the muscle cell, it's the fundamental contractile unit. It's where you have a single myosin filament and the two actin components on either side of it. They shorten and they lengthen by sliding over each other, yada, yada, the sliding filament theory. So at the level of the sarcomere, this is generally where we're looking at the length tension relationship. And so obviously, let me reverse that to help you understand it. Length tension relationship is the relationship, right? So it's a graph between the length of a muscle. Technically, it's the length of the sarcomere and the amount of tension that it is capable of developing. Remember, muscles develop tension, right? And a muscle belly, which is made up of hundreds of thousands, millions of muscle cells, and all those muscle cells are made up of myofibrils. Sarcomeres are the fundamental contractile unit. So when we dig down all the way into it, we understand force tension relationships at the level of the sarcomere. I hope that makes sense. And basically, it's the ability of the sarcomere to generate tension, individual sarcomeres to generate tension that tell us about the length tension relationship. So the length of the sarcomere, i.e., the total amount or percent of coverage that the actins have within the myosin itself. That percent of coverage is what determines the total amount of tension. And there's this sort of optimum length at which tension can be developed. If you remember, the myosin filament, or the myosin myofilament, has these heads that come off. I don't want to go too deep into the anatomy, microanatomy of it, but basically the myosin filaments have these heads that attach to the actin, and it's when they attach to the actin filaments, right, and then they'll swivel and pull the actins close to each other. That is what develops tension in the muscle. When all the sarcomeres, when all the myofilaments, right, all attach to each other at certain percentages and lengths, they're able to develop a certain amount of tension. When you get enough of those occurring inside of enough muscle fibers, right, then the entire muscle can shorten and subsequently lengthen. So the length and the tension are related by the total number of these, what are known as cross bridges. So when you take length tension relationship, you're really bringing it all, scratching below the surface. You're really ultimately talking about the total percent or capability to create cross bridges, right? Remember the cross bridge, like I just said, myosin heads on the myosin filament, the protein filament, attached to actins. Every time you have the head of a myosin attaching to an actin filament, that's what's known as a cross bridge. That's what ultimately, when enough of those occur, will create tension. And what we know, again, there's charts on this, and I'm kind of glad Ace didn't go too deep into it because it's not uber necessary to do that, but it does help to understand the basic concept. So the more cross bridges you generate inside a sarcomere, within all the sarcomeres, within all the muscle cells within a particular muscle, the more of those you can achieve, the greater the tension level. Now, here is the interesting thing is that as the sarcomeres shorten, I'm representing actins on either side of the sarcomere, as the sarcomere shortens and lengthens, this is the interesting thing, is that the potential for the actual cross bridging to occur changes. So the potential number of cross bridges that are available to occur are going to either increase or decrease. So as a sarcomere shortens, right, and the actins move closer and closer to the middle of the sarcomere itself, as they get closer and closer, the total number of cross bridges available to occur starts to go down. It decreases. So as a muscle cell, let's take it the muscle cell at the sarcomere level, as it shortens, its potential, right, the total number of cross bridges actually decreases. The length and the tension are related. So as the length decreases, the tension decreases. You get the idea? Length and tension. The relationship is really simple. As a muscle cell shortens, okay, just get the concept. As muscle cells shorten to their ultimate shortest length, right, the tension goes down. And then as you increase the length and as those actin filaments ride back over the myosin and that sarcomere lengthens, i.e. the muscle cell therefore lengthens, the tension development based on the length starts to go up. But as the cell lengthens and the sarcomere lengthens, it actually reaches a peak of tension development. And then when you lengthen that muscle cell and start stretching the sarcomeres out further and further, you start to see a decrease again in total tension development. So there's sort of this ideal length of a sarcomere that produces the greatest tension development. That's what the length tension relationship is basically saying. What does that have to do with your postural deviations? Well, duh. If a muscle or sarcomeres in muscles are inappropriately shortened, right? They're actually receiving too much neurological stimulus, and those sarcomeres actually start to shorten and decrease in length, you're going to miss out on optimal tension development. And when that happens, when one muscle starts to shorten, I'm going back now to this page 394, this picture, for instance, of postural distortions. When one muscle starts to shorten because of this increased activity to it, the antagonistic muscle has to lengthen to accommodate that. And that's what throws you off, throws your pelvis off, yada, yada. But the whole point with length tension relationships, now, by the way, they will also throw in force coupling relationship. I'm not going to go over that in this video, but the length tension relationship is, from that perspective, really simple to understand, I think, right? So the shortening of the sarcomere, therefore the shortening of the muscle cell, because sarcomeres run in series along each other, along the entire length of the muscle cell. As the length changes, the tension development goes up and goes down based on the length. And then there is a sort of optimal length where you have maximum cross-bridging capability at the level of the sarcomere. And this is what we see as we go through exercises, as we lengthen the muscle, we shorten the muscle, its potential for increasing tension or developing tension is going to be modified, right? Let's go higher or lower based on the length of the sarcomere, therefore the muscle cell. And that's how, that's normally how we understand length tension relationship. And you'll notice that we don't have to go really fully in depth in the explanation, hopefully for you to get the idea about the relationship that we're talking about, muscle length and its tension. Whew. I hope that was helpful. Look, if this was helpful, if this made sense, perhaps you had an aha moment when you were watching this, perhaps you didn't. But if you did, write understood in the comment section below for us. That helps us to know if these videos are helping students to understand the material in the ACE textbook. Also in the description box, go ahead and click on that link if you want access to the Body Design University ACE exam study course. Now that course has a lot of resources, right? So we have chapter level study videos. We have chapter level audio textbook, right? So the audio is actually available to you, plus quizzes, plus practice exams. We have an entire suite of Quizlet study sets specific to the chapters of the ACE textbook. So a lot of great stuff in there. Click on that link if you do want access to that. As well, let us know how we can be of assistance in helping you by writing in the comment section below. Every Wednesday night, just so you know, every Wednesday night, 6 p.m., 6 to 6:30 p.m. Eastern Standard Time, so 6 p.m. Eastern Standard, we do an exam study Quizlet live, sort of little game that we play with Quizlet. We create a scenario where you actually are competing against other students. It's a lot of fun, very helpful from a studying perspective. Just let us know if we can help in any way. Leave the comments below. By the way, if you have not subscribed, please do so. If you have not been to our Facebook page, please head on over there as well. Let's see if I can switch this around. If you've seen this in the Facebook, then make sure you come over to the YouTube channel and subscribe there as well. As always, have a great week. We'll see you next week. Bye.